morning, sir. This is our activity 9 from Dominic Vente Giganto and Kevin J. Carigo. Activity 9 is all about using the spigot, drill, pocket drilling, engraving, and yeah, those things to put into one workpiece. So we decided on this design as our finals because I think it's a fitting end for our class. So we started with top plane. We start with a center rectangle and extruded it into 40 mm. Then on top of the 40 mm we have another 10 mm of circular spigots, so resulting in 50 mm total in width. Starting with the circular spigots, we have a diameter, an inner diameter of 10 and an outside diameter of 20. So we put that there and extruded it to 10 mm, and inside the circles we just put a drill of 10 mm through all, so you can see here it's through all. And then after one design I just used the feature mirror here, linear pattern only, sorry. And it has a distance of, you can see here, I can't be able to show it, but it has a distance of 20 mm from each circle, and the distance from here to here is 75 mm. And for this design we use contour milling. First we put a rectangle and use the feature here, this ellipse with a radius of 4 here, 4. Then the same with the circular spigots, I just use the linear pattern to make the other features on the workpiece. So I think that's about it for the outer design. Oh, and I forgot to mention the outer rectangular spigot. It has a diameter of 10 mm, this curve here. So moving on to the inner design, we have our names and the subject name. But first I would like to discuss the so this is all engraving inside. We just extruded cut it to emphasize that it's in engraving. In the CAD it's 1 mm, but it looks big here. But in the Sinotrain it's just small. For the height of the letters, it has an inner height of 4.56 m and an outer height of 5 mm. And the spacing for each is just 1. And for the zigzag design, we also have a depth of 1 mm and a 5 mm from distance from line to line. So this line to here is 5 mm. So yeah, I think that's it for our activity 9. Moving on to the programming part with Kevin J. Carigo.
Good day to you, sir. I'll be explaining you our output and explain our program using the demo milling machine. So this is our output in Sinotrain. First thing we did was set our workpiece. The size of our workpiece is 160 by 210 and the thickness is 50. It's negative and it's black centered so that the reference point will be at the top in the center. Moving on, G G90 for absolute coordinates, G94 for feed rate setting in millimeter per minute, and G71 for metric units in millimeter. So chose 5 tools, one for drilling and 4 end mills for cutting with 5 different sizes. M06 for tool change, and I equipped this tool, this 12 millimeter diameter tool, and I set the speed to 1000, M03 for spindle rotation on clockwise, M08 for coolant on. After preparing, we now started machining. First thing we did was to fillet the edges, these edges here. The size of this workpiece was 160 by 210, so we used rectangle spigot to make it 150 by 200 and fillet the edges with the radius of 10. After this, we changed the tool to this 15 millimeter diameter cutter. All of this rectangle spigot here from this left to right, this may look complicated but is actually not. The reason why this is so long because the purpose of this was to clean this part right here so that only the circles will remain at the top of this surface here. So I'll just simulate it quick so that I can show you what all of these rectangle spigot from here left and right actually do. So first it started rectangle spigot to fillet the edges. After the rectangle spigot for fillet edges, it will now start digging to make this room for these circles at the top. It will clean also. It will clean this portion here so that it would only remain these 3 boxes and 3 boxes here so that it has room for these circles at the top. So I'll just cancel this simulation and proceed with the program. Going back to our codes, after cleaning the top part with a rectangle spigot, we now use circular spigot for these circles here at the top. I use a different tool with 12 millimeter diameter. This is for the left side, these 3 circles, and for the right side here, these 3 circles. I just copy and pasted all of this because they are all the same and only their reference point are different, so I just changed the reference point from each part and I just copied and repeated it 6 times because it has 6 circles. Then after the spigot, this middle circular pocket, this big circle at the middle. The depth of cut is negative 25. In Z0 I put 10 because so that it would start cutting at the surface because I already cut 10 millimeter portion here at the top, so I must start at negative 10. Next is drilling these 6 holes. All of these are through. The depth of cut is through. I put negative 55 so that it will cut through. I only use 1 drill bit for all of them because they are all the same, and I just repeated this cycle 83 and put different reference point because only the location is different. Then after this drilling, we now go to engraving. I change my tool first to this 3 mm diameter for engraving. Then I input the tool path for these lines, this zigzag line here. I input it manually because there is no command for this. After this, I started engraving the letters here. I use a smaller tool that's a diameter of 1 mm so that if it starts cutting, it won't merge the letters because they are too close to each other. Next is contour. First, I made a contour path here at the bottom. I just use contour. After making the contour path, I use contour call here and in the program to use the contour path that I made. All of these have just the same dimensions, all of this. So I just repeated it and just copy and pasted and only change their contour name and starting point. And so after making the contour path, I had to make a milk pocket, the cycle 63s, to make the cut and input the depth of cut. The depth of cut of this is 20. I started at -10 because the reference point is at 0 and I already made a cut of 10, so I'm start at -10 below. I just repeated this process because they're just the same. I only changed the reference point. Then after this, I put M30 to program end. So that's pretty much for our program. I just simulate it to show our finished output. That's all, sir. Thank you for watching. This is our activity 9 output.
Okay, thank you, sir, for listening.
Thank you.
Thank you and goodbye, sir.